The 1920s were supposed to belong to the engineers in spotless collars and polished drafting rooms, the men who believed machinery should be built once, standardized, and obeyed. But out on the dirt roads and farm fields, a different kind of mind was emerging. One man, armed with nothing more than hand tools, scrap steel, and a refusal to accept factory limitations, quietly committed an act of mechanical rebellion. He didn't petition a manufacturer. He didn't ask permission. Instead, he built something the professionals said couldn't work, an overdrive gear that rewrote the rules from the outside. Battle of the Iron Engineers. Picture the mid-20th century industrial landscape. America was flexing its manufacturing muscle, churning out steel and iron at a rate the world had never seen. But beneath the roar of the assembly lines, a quiet but vicious war was brewing. This wasn't a conflict fought with guns or treaties, but with wrenches, slide rules, and casting molds. It was an ideological schism that defined the golden age of machinery. On one side, you had the establishment, the centralized authority of corporate engineering. On the other, a new breed of mechanical renegades who refused to be told how to use their tools. To understand this battle, you have to look at the men in the high towers. We call them the white shirts. These were the degreed professionals working for giants like International Harvester in Chicago and Rock Island. These men were brilliant, disciplined, and utterly beholden to the system. Their philosophy was top-down. Innovation happened on a drafting table, followed by rigorous cost-benefit analysis, and finally, standardization. Their job wasn't just to build a tractor. It was to build 350 of them every single day, without a single hitch in the production line. To a white shirt, a machine was a finished product, a closed loop of liability and design life. Reliability was calculated in hours of operation, and success was measured by how little the factory had to deviate from the blueprint. But out in the field, away from the air-conditioned offices and the clean drafting paper, a different philosophy was taking root. This was the era of the hot rodder. These weren't university men. They were farmers, mechanics, and tinkerers who had watched the world transition from horse-drawn plows to combustion engines in a single generation. They possessed a knowledge you couldn't get from a textbook, empirical, bloody-knuckled, grease-stained wisdom. To the hot rodder, the factory specification wasn't the law. It was merely a suggestion. They viewed a brand new machine not as a finished masterpiece, but as a rough draft waiting to be finished. If a tractor couldn't pull a plow fast enough, you didn't write a letter to the engineering department. You grabbed a torch and fixed it yourself. This is the story of what happens when those two worlds collide. The saga of the M&W Gear Company is the perfect microcosm of this industrial feud. It pits the massive, slow-moving resources of International Harvester against three guys in a basement in Anchor, Illinois. You have the corporate titan focused on global production and protecting their legacy. And then you have Elmo Miners, Art Warsaw, and Lloyd Taylor, three pragmatists who looked at the flagship tractor of the day and saw a fatal flaw. They didn't care about corporate risk assessments or production complexity. They saw a problem that was costing farmers money, and they decided to solve it by doing the one thing the white shirts said was impossible. They were preparing to crack open the heavy cast iron transmission of a farmall tractor and rewrite the rules of gearing from the inside out. Big Red's fatal gear gap. To appreciate the sheer audacity of the fix, you first have to respect the canvas it was painted on. In 1939, International Harvester rolled out the Farmall M. This wasn't just a tractor, it was an industrial statement. Enthusiasts call it Big Red. It was the machine that powered the American Corn Belt through the Second World War and beyond. Under the hood sat the C-248, a massive four-cylinder, inline engine that churned out about 38 gross horsepower. It was heavy, it was overbuilt, and it was undeniably reliable. When an engineer in Chicago signed off on the Farmall M, they believed they had designed the ultimate row crop tractor, a mechanical masterpiece that would run for decades. And in terms of durability, they were absolutely right. But in terms of utility, they had baked a critical flaw right into the transmission case. The Farmall M was equipped with a 5-speed gearbox, and the logic behind those ratios was strictly rooted in the agricultural realities of the Great Depression. The engineers at Rock Island prioritized heavy draft work above all else. In the 1930s, the primary job of a tractor was to drag a plow through heavy soil, a task that requires immense torque and very little speed. Consequently, the first 4 gears were clustered tightly together. First gear was a creeper at barely under 3 miles per hour. Second and third were incremental steps up. By the time you shifted into 4th gear, you were topping out at roughly 5.5 miles per hour, with the engine screaming at its governed limit of 1,450 RPM. Then there was 5th gear. The engineers viewed 5th gear not as a working speed, but as a convenience feature. It was a dedicated road gear, designed solely to get the farmer from the barn to the field, or into town to pick up supplies. To keep production costs low and the design simple, International Harvester made 5th gear a direct drive. This meant it bypassed the reduction gears entirely, locking the engine speed directly to the output. It was a cheap, efficient way to get road speed. Here is where the logic falls apart. By treating gears 1 through 4 as work and gear 5 as travel, the engineers created a massive uninhabitable void in the middle. Look at the numbers. 4th gear ends at 5.48 miles per hour. 5th gear doesn't even wake up until you hit 17.39 miles per hour. That is not a step. That is a cliff. It represents a ratio jump of 217%. In the world of transmission engineering, a gap that wide is practically criminal. It created a dead zone between 5 and 17 miles per hour where the tractor effectively ceased to be useful. As the 1940s progressed, farming practices began to evolve rapidly. Farmers weren't just dragging heavy plows anymore. They were adopting new, faster implements like rotary hoes, high-speed cultivators, and specialized hay rakes. These tools were designed to operate most efficiently at speeds of 6, 8, or 10 miles per hour. This left the farmer in a maddening position. If he stayed in 4th gear to run his rotary hoe, he was crawling along at 5 miles per hour, wasting daylight and burning fuel while the implement barely scratched the dirt. But if he tried to shift into 5th gear to pick up the pace, the engine would instantly stall. The jump to 17 miles per hour was far too tall for the engine to pull any kind of load. And even if it could, the ground speed would be terrifyingly fast for field work. The farmer was trapped. He had a powerful, reliable engine and a legendary chassis, but he couldn't access the speeds he actually needed to do his job. The corporation's adherence to standardization and cost-cutting had resulted in a machine that was perfect on paper, but functionally broken in the modern field. It was this massive, quantified failure that opened the door for the aftermarket to step in. International Harvester had left a gaping hole in the market, and they were about to find out that nature abhors a vacuum. The hot rodders of Anchor, Illinois. The solution to International Harvester's massive engineering oversight didn't come from a rival corporation or a university research grant. It came from a collision of 3 distinct personalities who possessed the exact mix of desperation and genius required to break the rules. You had the money, you had the wit, and you had the inventor. It started with Elmo Miners. In this story, Miners is the catalyst. He was an Illinois farmer, and more importantly, he was a frustrated customer. He owned a 1941 Farmall M that he affectionately nicknamed Gramps. And every time he took Gramps into the field, he felt the financial sting of that gear gap. He was the one burning daylight in 4th gear, and he was the one stalling out in 5th. Miners wasn't just a financier. He was the end-user advocate who provided the capital and the empirical rage necessary to turn a complaint into a business. He knew exactly what the machine was failing to do because he was the one sitting in the seat. Then you had Art Warsaw. If Miners was the drive, Warsaw was the hands. He was a master machinist and fabricator, the kind of guy who could look at a complex mechanical concept and instantly understand how to cut it out of steel. Warsaw was the bridge between theory and reality. His talent for production was so profound that years later, after selling his stake in the partnership, he would go on to develop the A&W dynamometer, becoming a legend in engine testing. But in the late 1940s, his job was to take a radical idea and make it manufacturable. Finally, there was Lloyd Taylor. Taylor was the mechanical brain, the inventor who operated completely outside the box of agricultural tradition. He wasn't interested in maintaining the status quo. This is the man who would go on to design engines for automotive outliers like Crosley and the Chevrolet Corvair. He was a hot rodder in the truest sense, a man who saw mechanical limits as challenges rather than boundaries. While Miners and Warsaw built the company, it was Taylor's specialized understanding of gear design that unlocked the actual solution. The most incredible part of this operation wasn't the people, but where they worked. International Harvester had millions of square feet of factory space and armies of draftsmen. The M&W team had a basement in Anchor, Illinois. This is where the real work happened. Imagine the physical commitment involved here. To prototype their solution, they couldn't just run a computer simulation. They had to physically drag a massive cast iron tractor transmission into a residential basement and split it open. Working in that cramped, improvised laboratory, they had an advantage that the engineers in Rock Island never had. They had speed. There were no committees, no cost analysis meetings, and no bureaucratic risk assessments. When miners found a problem on Gramps, he told Taylor. Taylor drew up a fix, and Warsaw machined the parts. That tight, circular synergy allowed them to iterate with a velocity that a large corporation simply could not match. They identified a market failure and engineered a mechanical correction in real time. In doing so, they didn't just fix a tractor, they established the foundational template for the entire independent performance industry, drilling through the iron case. The genius of the M&W solution lay in its constraints. The team in Anchor knew they couldn't simply cast a brand new transmission case. That would have required an industrial foundry and millions of dollars they didn't have. They were stuck with the original International Harvester architecture, a massive, immovable cast iron box. Their only option was to perform surgery inside that box, utilizing the wasted negative space that the factory engineers had left behind. The breakthrough came when Lloyd Taylor realized the key to the entire system wasn't the main gears themselves, but the countershaft. In a standard transmission, power flows from the engine, through the input shaft, down to a countershaft, and then back up to the main gears. The M&W team designed a compact secondary set of constant mesh reduction gears that tucked neatly into the front of the transmission housing. When the farmer engaged the M&W lever, this new gear set effectively overdriven the input, spinning the countershaft faster than stock specification. Here is the math that changed everything. Because first, second, third, fourth, and reverse gears all rely on that countershaft for their power. Speeding up the shaft proportionally sped up every single one of those gears. Instantly, the farmer had two choices for every working gear: normal and high. The original 4 field speeds were now 8. But the real brilliance, the part that makes this a masterpiece of hot rod engineering, was how it interacted with the problem child, 5th gear. Remember that International Harvester had designed 5th gear as a direct drive to save money. In 5th gear, the transmission locks the input shaft directly to the output shaft, bypassing the countershaft entirely. M&W exploited this design choice to perfection. Because their kit only modified the speed of the countershaft, and 5th gear ignores the countershaft, engaging the overdrive had absolutely no effect on the tractor's top road speed. This was the direct drive trick. It allowed M&W to fill that fatal gap between 5 and 17 miles per hour with new, critical working speeds, roughly 6, 8, 10, and 12 miles per hour, without turning the tractor into a 30 mile per hour death trap on the highway. They had successfully inserted a modern transmission into an antique case, giving the farmer exactly what he needed while preserving the safety limits the factory had intended. As a bonus, because the PTO and hydraulic pump were also driven off that accelerated countershaft, the kit boosted hydraulic performance and allowed implements to run faster at lower engine RPMs. But buying the kit was the easy part. Installing it required a radical act of faith. The M&W 9-speed was engaged via a new external shifter rod, and there was no factory provision for it. To install the unit, a farmer had to take a heavy drill and bore a hole right through the thick cast iron side of his transmission case. This wasn't a bolt-on accessory. It was an irreversible modification. Drilling that hole was a physical declaration. It was the farmer admitting that the manufacturer had failed him, and that he was willing to void his warranty and permanently alter his capital equipment to fix it. It was a violent, necessary act of ownership that separated the operators from the owners. The dealer network Trojan horse. The basement laboratory in Anchor, Illinois, was quickly overwhelmed by the sheer volume of orders. The demand for the 9-speed kit was so explosive that the trio had to abandon their subterranean workshop, moving first into a converted schoolhouse and eventually establishing a massive, dedicated manufacturing facility in Gibson City. But while the scaling of production was impressive, the true brilliance of M&W lay in its distribution strategy. Elmo Miners understood the corporate ego better than most. He knew that walking into the International Harvester headquarters in Chicago and pitching his invention to the white shirts was a waste of time. The engineering department was invested in defending their original design. Acknowledging the need for the M&W kit would be an admission of failure. So, Miners bypassed the boardroom entirely and executed a brilliant Trojan horse maneuver. He went directly to the dealerships. This was a masterstroke because the dealers were the ones on the front lines. While the engineers in Rock Island were celebrating their standardization metrics, the local dealers were the ones enduring endless complaints from farmers about the tractor's sluggish performance. To a dealer, the fatal gap wasn't an engineering abstraction, it was a daily headache that cost them sales. When M&W walked in with a box that solved the problem, the dealers didn't see a voided warranty. They saw a customer retention tool. The infiltration was so successful that it created a bizarre anomaly in the new equipment market. Dealerships began installing the M&W 9-speed transmission on brand new Farmall M tractors before the customers even took delivery. Think about the implications of that. The official representatives of International Harvester were taking factory-fresh machines, drilling holes in the transmission cases, and installing aftermarket gears because the stock product was functionally incomplete. It was a silent mutiny. The distribution network had tacitly admitted that the hot rodders knew more about what the tractor needed than the people who built it. With the cash flow secured from the transmission kits, M&W didn't settle. They realized that once they had given the farmer the ability to drive at 8 or 10 miles per hour, the tractor would need the muscle to actually pull an implement at those speeds. The stock 38 horsepower wasn't going to cut it. This led to the expansion of the hot rod catalog. M&W began re-engineering the entire powertrain. They introduced add-power high-compression pistons and larger sleeves, effectively boring out the engine for more displacement. They developed stroker crankshafts, advanced governors, and even pioneered live PTO and live hydraulic systems, features that allowed the hydraulics to work even when the clutch was depressed. By the early 1950s, M&W wasn't just a parts supplier. They were effectively functioning as the unauthorized research and development branch of the industry. They were proving that the aging Farmall M could still be a competitive, high-performance machine if you were willing to ignore the factory specs. They weren't just fixing a flaw anymore. They were pushing the entire industry standard forward, dragging the reluctant manufacturers into the modern era, one drilled hole at a time. The right to modify. The victory of the M&W Gear Company was far more significant than just a healthy balance sheet. It was a philosophical triumph of the field over the factory. The conflict boiled down to a single question of priorities. The engineers at International Harvester prioritized standardization, component longevity, and risk aversion. They built a tractor designed to survive, but they forgot to build one designed to evolve. The hot rodders in Anchor, Illinois prioritized one thing above all else: utility. They understood that a machine's value is defined by its ability to perform the work required today, not the work that was required 10 years ago. The ultimate validation of the M&W philosophy came when International Harvester finally attempted to solve the problem themselves. Years later, on the Super MTA and the 400 series tractors, the corporation introduced the torque amplifier. It was an on-the-fly splitter that attempted to do exactly what the M&W kit had been doing for a decade. But while the M&W unit was a robust mechanical set of gears, the factory solution was a highly complex, fragile system that became notorious for mechanical failure. The irony is palpable. The massive corporation, with all its resources, arrived late to the party with a solution that was less reliable than the one cooked up in a basement. The aftermarket hadn't just filled a gap. They had set the standard that the original manufacturer was forced to chase. This legacy is actively preserved today, both physically and digitally. Elmo Miners' original test tractor, the legendary Gramps, still exists as a monument to this bottom-up engineering. In the digital age, mechanical evangelists like the channel Driving 4 Answers have taken up the torch, breaking down the physics of these modifications for a new generation. They frame the M&W saga not as a dusty footnote of agricultural history, but as a masterclass in mechanical problem solving. But the deepest resonance of this story lies in the modern battle for the right to repair. When those thousands of farmers took a heavy drill to the cast iron transmission case of their Farmall M, they were doing something profound. They were drilling a hole through the concept of corporate authority. That irreversible modification was a physical assertion of ownership. It defined the implicit contract between man and machine. Once you buy it, it is yours. This 1940s rebellion is the direct historical precursor to the modern fight against locked software and sealed hardware. It established that the expertise required to improve a machine often resides with the person in the operator's seat, not the person at the drafting table. SM&W proved that when an original equipment manufacturer fails to deliver essential functionality, the owner has the undeniable moral right to engineer a solution. Whether it is soldering a new chip onto a circuit board today, or bolting a new gear set into a tractor in 1948, the principle remains the same. Innovation driven by necessity will always supersede control driven by bureaucracy. Victory of the basement engineers. In the final analysis, the conflict between International Harvester's design logic and the M&W Gear Company's practical ingenuity reveals a fundamental truth about industrial innovation. Design authority should never be divorced from operational necessity. The engineering team at International Harvester succeeded in their primary mission. They created a tractor that met every internal metric for reliability, cost-effectiveness, and standardized production. But that cautious, top-down approach resulted in a crippling 207% gear ratio jump that rendered the machine profoundly inefficient for the changing world of agriculture. The hot rodder team, conversely, prioritized utility above all else. They looked at that massive gap between fourth and fifth gear and didn't see a safety feature. They saw a design flaw. By engineering an elegant additive solution that capitalized on the transmission's original direct drive mechanism, they maximized field efficiency without compromising the road safety or stability of the tractor. They managed to outsmart the original designers by using the architecture of the machine against itself. The M&W 9-speed transmission was not merely an accessory you bought from a catalog. It was the restoration of functional utility to the backbone of American agriculture. By convincing thousands of farmers to take the radical step of drilling a hole through their transmission case, Lloyd Taylor, Elmo Miners, and Arthur Warsaw secured their legacy as true engineering disruptors. They successfully challenged an entire corporate structure and provided undeniable proof that the most valuable, market-driven innovation often originates from the bottom-up pragmatism of the end user, not the top-down conservatism of the centralized drafting table. They proved that while the engineers might own the blueprints, the hot rodders own the road.